Morning, guys. Today we're going to take a look at page 8 of the unit page 8 of the unit 8 classwork packet. Sorry about that. Once again, page 8 of the unit 8 classwork packet, and we're going to take a look at some algebraic examples of solving problems with parallelograms. The first one we're going to do is example number 9. Now, example 9 gives us two pieces of information. They tell me that this whole thing, let me use a different color here, TV is 74, right? And then they give me that WV is 4x plus 1. So this piece of it is 4x plus 1. Okay, now which property of parallelograms are we going to be using here? We need to use the fact that the diagonals of a parallelogram bisect each other, meaning they split each other in two equal parts. So in other words, if this is 4x plus 1, what do you think this piece would also be? That would also be 4x plus 1. Now, if I were to combine these together, what would I get? Like, how long is it? It's 74. So my equation in this case then is actually 4x plus 1 plus 4x plus 1 equals 74. It's actually a segment addition problem dating back to unit 1. Combine like terms to get 8x plus 2 equals 74. Subtract 2 from both sides to get 8x equals 72. Divide by 8, and I get x equals 9. Bam. Done. Let's move on now to example number 11. Example 11 is not terribly difficult. It just requires a different property of parallelograms. In that case, do you guys notice how angles A and C are opposite each other, meaning they're in opposite corners of the parallelogram? We learned before that opposite angles of a parallelogram are congruent. So congruent in algebra would basically mean set them equal to each other. Let's go. So my equation here would be 6x minus 15 equals 4x plus 11. Then I do some inverse operations, subtract 4x from both sides, add 15 to both sides, divide by 2, and I get x equals 13. But I'd be wrong. Why am I wrong? All my work is right. I hope it's right. The reason I'd be wrong is I didn't read the question. The question didn't ask me to find x. It actually asked me to find this angle over here. So here's what I gotta do. Choose one to plug back into. I'm gonna plug back into this one right here just because I see smaller numbers, right? So 4 times 13 plus 11, that's 52 plus 11, which gives me 63, right? Okay, so I know that the angle C is 63 degrees, but that's not what they asked me for. They asked me for angle B. This is where I need to use one additional property of parallelograms, which is that parallelograms have consecutive angles, meaning angles that are next to each other that add to 180. They're supplementary. So if this is 63, how many degrees does that leave over here? Well, 180 minus 63. So let's see how that works, okay? And I get 117 degrees as my answer. So with the algebra problems, a lot of times you're going to find them to be easier than the non-algebra problems. The trick is just making sure that you take a look at what you're given and you determine which of the 5 properties applies to set up your particular equation.